Welcome to this task script tutorial. This is tutorial number 4, HTP Smart Junction Box unboxing. So here we see our HTP junction box. Actually, it is a full-fledged PLC with 12 inputs and 8 outputs. Of course, there is a datasheet which publicly shows all the features of our device. So the main feature, hardware and software features, I/O mapping of the connectors, and so on and so forth. But the purpose of this tutorial is to show you briefly how it works and how we can interact with this device, which is so simple yet so powerful. So here we have already connected it to our power supply connector, which provides the 24 volts, and to the communication connector, which connects Ethernet and USB in this case. This is a typical situation for development where USB is used along with Ethernet. Of course, for production, only Ethernet will be used here. So we will use another cable which only has Ethernet going out from this connector. So just a short glance at the connectors. We have here 4 input connectors, each one with 3 ports for a total of 12 input ports. So port 1, 2, 3, and 4. Then we have 4 output connectors with 2 ports per connector for a total of 8 ports. Ports 1, 2, 3, and 4. Okay, so we can now just turn on power. If we are interested in development only, we can only provide power through USB. So now I have plugged only the USB cable. CPU has started working, and we will see it through this LED, which we call a live LED. This LED blinks at a specific rate, which is 5 pulses every 2 seconds. And this will indicate us that it is running in production mode, in normal mode. There is another mode which is development, which we will see later on. Also, we see here from the way this LED is blinking that no Ethernet is connected, because the LED goes from full lit to full dark. If Ethernet is connected, LED goes from full lit to half lit, showing in this way that the Ethernet carrier is detected, and so it shows us that the Ethernet cable is correctly connected. In case we connect the Ethernet connector, but we don't have the Ethernet LED lighting pattern, it means that the cabling is not correct. So I will just connect the Ethernet to show which is the correct blinking when Ethernet is connected. Here we go. So we see that the same live LED goes from full lit to half lit, and this let us understand that Ethernet is connected correctly. I will unplug it just to show it once again. So now the LED goes from full lit to full dark, where Ethernet is not connected. Now we connect it, and the blinking goes from full lit to half lit, and this is a very specific pattern. Okay, I can also turn 24 volts on now, and in which will power the I/O circuitry, and in particular it will power the output LEDs, and so we will see this LED blinking pattern, which is built in the program, which is deployed as factory setting. Of course, we don't need USB in production. So now that I have powered the 24 volts, I have just unplugged USB and everything goes as well. But since I want to develop, to do some development operation, I would plug the USB back again because USB is needed for development. In particular, when we run the Task Script Studio, which is our development console, it will need both USB and Ethernet connection to work. Okay, so here we go. I only check the settings. I recommend checking the settings because we have to make sure that the settings are compatible with the actual type of board that we are using. In this case, USB here is okay. Network interface is Ethernet, and the address here is correct. So everything is okay. And so we are ready now to issue our discover command. Discover command is issued, and it returns the answer provided by the junction box. We see here, first of all, the IP address 192.168.1.103. This address looks like generated from automatically from the router through the HTP protocol. But of course, the junction box also supports fixed IP, so for application where they need it. This is the serial number. This is the model of the junction box, which is consistent, and this is the program which is actually running on the junction box, and this is, as we know, the program which is installed at factory. So we already have this program here, the source code of this program, because it is deployed. It comes along the installation package. So I have just opened it. So I can now refresh the controller state and obtain the controller state from the junction box to the program. I can refresh it. So every time I hit this button, the controller takes one snapshot at that very specific moment. So this is how this specific factory program is written. We have two tasks active at the same time concurrently. One is a web service server, and the other one is just this program which leads the LED. And so we can take those snapshots. Well, so far so good. I would now like to show one other feature of the controller. Now that we obtained the address by the discovery, we can 92.168.1.103. We can call the controller, and this is the answer that we get. Basically, it is a subset of information that we achieved from the discovery. But so this is still is the IP address, MAC address, and all the stuff. But we could also interrogate the web server, which is this task running here. To be more precise, it is not a general purpose web server. It is a web service which is built in here to provide information. And in particular, now I have sent a web server GET to the server, and this is the information that I received in JSON format. So I can issue repeatedly these commands, and I will get some specific information. And in particular, the first field here is just the counter of the poles. You see that increments. So I don't want to go inside this task. It is too early to try to understand how it is built here. But this just to show this feature. So when we need our controller to be accessed from a web browser page, we can easily write a web page which polls our device, and our device is ready to answer. So I think we can stop here this tutorial and just recap what we learned. In particular, the position of the connectors and the pattern of the alive LED, which shows two types of information. One information is that the CPU is running, and the other information is that Ethernet is connected, as it is in this case when the LED goes from full lit to half lit. Okay, thanks for watching.